Hi, I'm Meta Spencer, and today I would like to say we're going to the Arctic, but actually I don't want to go to the Arctic ever. It's not my kind of place. But certainly there are some two friends here with me who do go to the Arctic and enjoy it and know the way around even. One of them is Peter Wadhams, who's a professor of ocean physics at the University of Cambridge and specializes in Arctic sea ice, I think. And the other is Thomas Garreau, who is the CEO or what, president or something. I think it's the Coral Reef Alliance. Have I left a word out?
Global Alliance, yes, yes.
Okay, and so I think you spend more of your time in very warm water. And you've been recently in the Maldives, haven't you? But you certainly know and are concerned about some of the recent things that have been going on. Because we are experiencing very recently another sharp increase in the warming of the Arctic, but more generally, there is a lot of talk the last few weeks, couple of weeks, about the rapidity with which the whole global warming is taking place, so that James Hansen and others are warning us, as if they hadn't warned us plenty before, that we better pay attention to these dramatic and very disturbing developments. So I have two friends here who are, I think, going to start off by talking mostly about what has been going on recently in the Arctic and why we should worry about the ice there. Tom, you're the one who alerted me to this. I know that Peter is the expert on Arctic sea ice, but can you tell me what happened about 3 days ago?
Yes, thank you. It's a pleasure. It's actually a week ago today, on February 2nd. Now, Peter Wadhams is the authority on Arctic ice. He's the person who basically, developed the method for measuring how thick Arctic ice was from underneath from submarines, as they were melting everywhere near their melting away on top. But anyway, so he's the authority on this, and I work in the warmest waters. I hate to be cold. So I'm a Jamaican coral reef guy. And what concerns me is when it gets really hot and corals bleach and die. And back in the 1980s, I developed the method for predicting coral bleaching satellite sea surface temperature data by mapping extreme high temperature events, which is what correlated with bleaching. And so I've been tracking those worldwide ever since the 1980s. It's just every morning I look at the latest satellite data and see where it's hot and where it's not. And on February 2nd, what I noticed was exceptional warmth at the North Pole over the Arctic Ocean. Now, this is not new. It had actually been going on for about a year. But on February 2nd, it was so warm, it was about 30 degrees C above the average temperature for that time of year at the North Pole. And it actually got above melting temperature. That is to say, the ice, was beginning to melt in the daytime at the maximum temperature. And that was February 2nd. That's the coldest time of year. That's absolutely astonishing. So I posted something on it on the web saying, listen, this is incredible. I mean, and I expected fully that it would be the number one item on the news later that day, which, of course, turned out not to be the case, was utterly ignored. And I circulated it to a few people in the climate network of people, including people like yourselves. But it didn't, the press never noticed. The next day, there was nothing about it. It's only 2 days later that the European Space Agency Copernicus announced, and they said exactly what I'd said. So it was extraordinary. That heat is still there. It shifted a little bit, shifted over into Siberia, as a matter of fact. It shifted to the Russian side of the Arctic. And in fact, most of central Siberia right now is above melting temperature.
Really?
early February. Again, that's absolutely extraordinary. But we're not hearing much about the weather in Russia at this time for a lot of reasons. So, but it is an exceptional event, and it's kind of terrifying that it happens so early, and it's something that I think we should be really shocked about. And it's. I will mention a little later. I'd like to, let Peter discuss that a bit more, the importance of it. But I'd like to come back to what's happened last year as a whole, because I've just submitted a paper to Oxford Open Climate Change on the sea surface temperature anomalies in 2024. We've mapped those worldwide. And again, I'm focusing on what's happening with coral reefs and ocean circulation change. I think we'll talk about that in another show, not now. But at any rate, the thing is, I've been following these changes in the Arctic, and it's been exceptionally hot in the Arctic all year. And what's the exceptional event for last week was, in fact, a continuation of a pattern that had been going on pretty much all year.
Mhm.
And in fact, temperatures north of Spitsbergen right now are what I call a coral bleaching hotspot. They're above a couple degrees C above the average temperature in the warmest month of the year in early February. I mean, that's incredible. So I'll let Peter talk about that now.
The things I was going to point out are that there might be something more complex going on, which is that marine heat waves are also happening in the Arctic and as well as the Antarctic. I would have thought that you will be able to describe the marine heat waves just empirically and get a handle on how many there are just from observations.
Well, let me just continue a bit with what is happening now and this last year, because last year was the hottest year in history all over the place. And as I say, right now, north of Spitsbergen, the temperatures are above a couple degrees above what they should be in the middle of August, which is the warmest time of year. They're right now at exceptionally warm temperatures. Now, last August, when they were at their maximum temperatures, they were up to 7 to 9 degrees C water temperatures above the average for that time of year in August. And there were exceptionally high temperatures in the Arctic Ocean. And I was tracking them at that time as well. And what I noticed at that time is that on August 11th of 2024, there was a sudden exceptional pollution event in the Russian Arctic. It occurred over the shallow Arctic Ocean in areas west and also northeast of Novaya Zemlya Island in the Russian Arctic, where suddenly on August 11th, intense pollution turned on of basically almost all the pollution gases that you would expect from a massive explosion. And they were the largest source of carbon monoxide on the world for about 11 days until August 22nd, when they suddenly turned off. It was an exceptional pollution event in the Russian Arctic in August. And again, I posted on that.
Tom, are you saying
it's never been published? Yes.
Mm-hmm. Was this an underwater explosion in the
Well, it's baffling. It's baffling to me what it was. The location, that the source area was actually in shallow waters of the Arctic Ocean, west of Novaya Zemlya, and also in a couple areas of islands to the northeast of Novaya Zemlya in the northern Russian Arctic. Now, these are areas that are, among other things, nuclear submarine bases, among other things, and are well known to be areas of intense disposal of nuclear and chemical and biological wastes, among other things, that have been disposed in that area. But the thing is, when the temperatures reach exceptional temperatures, I say 7 to 9 degrees above average, and they were at that range for nearly 5 months above average in that area, this whatever happened suddenly turned on there in the Arctic. And it was not a forest fire. I was tracking the major forest fires in Siberia and Canada, in the Congo Basin, Amazonia, and also the carbon monoxide sources from China and India, which are the world's largest, deliberate anthropogenic pollution sources. But at that point, the forest fires were overwhelming, even what China and India could produce with people burning coal and charcoal, every morning to cook their food. It was just staggering, the amount of pollution last year, atmospheric pollution that came from forest fires. But this event was about as big. That was what was extraordinary. And again, I posted some stuff on that on some of the climate webs. I expected it to be #1 item on the news. It's never been reported in the news ever at any point. I'm trying to put this stuff together, but it was extraordinary because of not only carbon monoxide. I track Windy, which is a weather source. It doesn't show methane. It doesn't show CO2. It shows carbon monoxide. It shows nitrogen oxides, sulfur oxides, particulates, aerosols, and a whole bunch of things that come are the major sources of combustion. So we can distinguish combustion sources by looking at the different gases that are produced, and the signature of the many different gases that suddenly went up on the August 7th and suddenly disappeared on August 22nd. That was so bizarre, just right up and right down. All these things kind of went in synchrony, except there's one gas that showed no signal at all, and that's methane. Now, my initial suspicion would be that this might have been the so-called methane time bomb. We can talk about that a little bit. I think that's something that will interest your audience a lot. But there's a lot of concern that as the Arctic warms up, that methane might be suddenly released. It's been frozen beneath permafrost or released by melting, and that there could be explosive events that might result in sudden warming. And there's a so-called methane time bomb. There's some concern about that. And that was what I suspected. Could this be the famous methane time bomb? And the answer is no. There was no methane signal. So whatever it was utterly baffling. I have no idea what it was. But what it does tell us is that there's no one monitoring or following extreme pollution events in the Arctic. That whole system has collapsed. The Russians aren't reporting anything. Nobody else is either. And I would have thought, listen, I'm not paid to monitor global weather in the Arctic. There are a lot of people who are being paid to do this stuff, like the World Meteorological Organization, governments, and all that. Why didn't they report it? Why is a coral guy from Jamaica looking out for coral bleaching the person who sees this stuff? It's beyond bizarre to me, But anyhow, I'm going to write up something on that event. But anyway, it was.
Well, let me ask you if I
very
can.
concerning. Yeah.
Can I ask you some questions about what one might guess? I mean, I have heard for years, of course, that there are immense quantities of methane in the bottom of the various places in the Arctic Ocean, and
That's right.
indeed there's a possibility that there was a considerable debate about how risky it was, how likely something like that would be, and considerable disagreement, I think, among experts. Nobody knows, everybody's guessing. But, some people think, 1,000 years from now it might happen. No. Well, now, if there's a huge amount of methane someplace, would these other gases be mixed in with it so that if you had an explosion of some kind from the ocean, that you would expect to see all of these gases together, or would you have expected it just to be almost exclusively methane? And which would mean that if you have a large quantity of the other gases in the as you test the locations, then they wouldn't have been that would have been a separate source. How would you have expected these things to be combined in a deposit under the ocean?
There's various potential sources. There's what we've been talking about. What is a mystery source, which apparently is not methane. Although that's the thing that always is suspect when there's something dramatic happens. If there isn't any methane involved in this, then we have a real question. The only other thing I can think of is that in the period between Christmas and New Year, there seemed to be a situation developing where funneling going on of warm water, warm air up to the Arctic. It could be therefore simply a sudden warming effect due to this hot air. So a natural phenomenon which happened to hit at a time which made kind of headlines because of the magnitude of the warming and the speed of it. Probably not explaining myself too well because I'm still suffering from a stroke. But I can see how something like that might develop.
I could imagine why, if you had an underwater explosion, you would see a huge burst very quickly. It would show up very fast, but Tom has said that it also vanished very fast. I'm just trying to imagine. I would have thought that if some kind of gas explosion took place, that it would not dissipate instantly. Certainly not as rapidly as it appeared, because it would diffuse, away gradually, wouldn't it? And it would be a slower diminishing than it would be an emergence. So
that's what you expect. That's what you'd expect. But I mean, basically, you did see some of the pollution stuff drift off towards the North Pole, towards the Arctic, including particulates and aerosols that were produced by this explosion. So that's going to be producing dark material that's going to change the albedo of the Arctic ice. I'm sorry that Uliana couldn't join us because she's now heading to the Arctic to measure that. That's what she does, for a living, is she measures dust and stuff on ice and on glaciers. She's an authority on that. So really, when she comes back in a few weeks, it would be really interesting to find out what she's learned. But anyway, there was a large amount of stuff, but there was no methane, and that's what's so bizarre. Is with any kind of explosion, there would definitely be a methane signal, but what there were signals of massive combustion of everything else but methane, and that's what's so strange. But as I mentioned, this is an area where a lot of dangerous wastes have been dumped in rusting barrels for decades. And who knows if the warming events caused something to rust and a chemical explosion to occur. I don't really know, but it turned on suddenly and it shut off suddenly, and that's very strange. Now, and it had the signal of a huge explosion event, because the amount of carbon monoxide in these gases produced was one of the world's largest pollution sources for those 11 days. So it was not small. Now, an explosion there, let's say, I mean, I'm no expert on nuclear submarines. Peter has been on a lot of them. But the point is that there are a lot of sonar monitoring stations all over the Arctic where people are trying to monitor each other's nuclear missile submarines and all that sort of thing. And an explosive event like that could not have gone undetected, in my view.
Now talking about, not about chemistry, we're talking about human deceptiveness. What, politics of why people do or don't say what is going on. That is a whole different conversation.
It is.
It is the big one that we all need to understand, is why people are thinking the way they are and why they're so, denying things. But also the politics of why you would disclose something or not disclose something for military reasons. Is that what you're hinting at?
Well, I'm sort of hinting at that. I mean, there are definitely thermonuclear reactors up there, because you can see the signal from the atmosphere of the kind of things they're producing. Okay, and there are a lot of bases up there within the Arctic Circle, as a matter of fact. I mean, they're secret, but you can actually see the atmospheric signals of these things. So anyway, so there's a lot we're not being told for sure. But I mean, I want to come back to the methane bomb issue because, as you pointed out, there's enough methane and CO2 frozen under permafrost and Arctic ice that were it to be released quickly would, in fact, could be a bomb. Now, the thing about the methane is that it was first raised by a Russian researcher called Shakova, and she was and her colleagues in Russia were measuring methane in the Arctic Ocean. They were finding huge amounts, and they were finding places where it was bubbling right out of the sea floor, in places where there would be, huge bubbles coming that you could light a match to inflame. Okay, and she did some incredible work on that. She wound up, I mean, later moving to Alaska, I think, with the collapse of the Soviet Union. But she and her people made an alarm. Then it disappeared from public attention. Now, I have been in touch with Russians measuring the permafrost in the eastern Arctic, and that's where she was really concerned about the Laptev Sea. And they say that, in fact, there's not much peat down there, and they're not worried about a methane bomb thing. They think there isn't enough methane, and they think there isn't enough peat there to really be an issue. Now, the thing that's odd about it is that with all this methane clearly that Shapkova showed was bubbling out of the Arctic, you'd think you'd see it in the atmosphere, but we're not. That's the thing. I mean, there are Arctic chemistry monitoring programs that are underway. They're mostly flying U-2 spy aircraft at high altitudes. They can't tell where things are actually coming from on the ground because they're so far up in the atmosphere. But the point is, they're not seeing an elevated methane signal. They're seeing a lot of variability. They can't make any sense out of the variability. It's so variable that, in fact, they can't make out any trends out of the stuff. And so there are people kind of measure. So if that methane's coming out, it's disappearing en route. Now, I did, in my PhD thesis, I worked on methane oxidizing bacteria, among other things. All soils are full of them. They eat methane out of the atmosphere. And so what happens is, and methane and oxygen are their only foods. That's all they eat. And so when methane increases, they're very slow-growing bacteria, but when methane increases, they proliferate, and they basically eat it all if they can. And that happened in the Gulf of Mexico oil spill, when huge amounts of methane released into the Gulf of Mexico. The oceanographers rushed to the Gulf of Mexico to try to use the methane to track the movement of water, and it was all gone before they could get there to measure it. The methane consuming bacteria eating every bit of it. So something like this seems to be happening in the Arctic, but that doesn't mean you could not have an explosive event. And now that's where you need to look at the geology. And the fact is, there's clear geological evidence of explosive methane events that we have not witnessed. And those are at least three different periods where those show up. First of all, about 120 to 130,000 years ago in the last interglacial, the so-called Eemian period, when it was about 1 to 2 degrees C warmer than it is now, and sea levels are about 8 meters higher than they are now. At that point in the Eemian, in the Arctic Ocean, there are these huge explosion craters that show up in that period of time when it was warmer than now and sea level was very high all across the Arctic. And there do appear to be these fossil explosion craters sitting in the sediments of that age.
Are you talking about underwater craters, or are you talking
They seem to be in marine sediments. That's what the papers suggest. And that was 100. And then about 15 to 11,000 years ago, at the end of the last ice age, when there was sudden warming, that was the warming of the previous warm event, 120 or 130,000 years ago. It got suddenly a lot warmer. I study the fossil reefs in Jamaica from that period of time. We can see that sudden rise of temperature and sea level in the coral reefs in the tropics that would happen in the Arctic. They're clear. But then 15 to 11,000 years ago, at the end of the last ice age, you went through a period called the Younger Dryas, where it was warming up, and then it suddenly got very cold again, and then warmed up again. Okay, and this was about 15, 11,000 years, that rate, 14, 12,000 years, that period of time. Somewhere in there are also large explosion craters in Arctic sediments. Okay, that's one thing. And then the third thing is that in Siberia, there are these massive craters that appear to have been the results of huge methane explosions that no one's ever seen or heard, as far as I know.
Now these
but
are recent though. I've seen pictures of those. In fact, I think Nova or one of these TV shows had a whole hour
Mhm.
about those. I saw three or four of them. They're like two or three city blocks in
Yeah,
size and
Mm.
perfectly circular. And
yes.
so far as I think they were implying that these are not archaeological or
Mhm.
not Paleolithic
Oh,
or anything. These
they're,
are
they're
these are
baffling.
recent that maybe they're going on now, you
Yeah,
know.
they're baffling. Now, you see, one thing about methane is that methane has a very short lifetime in the atmosphere, well, less than 10 years or so. So if you get a huge methane burst, it doesn't last very long. And the ice cores don't record that because the ice cores are recording the ice after snow has turned into ice. So there's a time lag after it. So a very short event might be missed in the ice cores. And Dr. Weldeab at University of California at Santa Barbara, who I hope could join us here, has found what seems to be evidence of methane bursts in that period of time, the Younger Dryas, about after 15,000 years ago, because the methane that gets released from the Arctic has a very distinctive isotopic signature. The carbon is very isotopically light. And the thing is that it's hard to find an evidence of a methane burst in the ice cores because, I say, they're so short that it doesn't get resolved easily in the ice core records. But he's finding records of that in sediments off West Africa that show the isotopic signal of a methane burst at that time that might have been too short to show up in the ice core records. So that there's possibilities of that. So there's very interesting evidence that suggests that this is a real possibility we need to be aware of and planning for and be monitoring for. And that's not happening now.
Mhm.
So what you're saying is that despite the fact that you don't see a methane signal in the gases produced at the moment, there may actually be one that simply the gas is emitted too rapidly or too you don't have time to see it before it's gone, although it's had an effect. Is that what you're saying?
Well, that's what C. Weldiab was saying, but that was again for the bursts in the Younger Dryas, or before the Dryas period. So in other words, it doesn't. There is a very small signal in the ice core records, but the resolution isn't very good in the ice
Mm.
core records. That's the point. I mean, a methane burst could have happened that you wouldn't pick up, but with the isotope signal being so much stronger, he says he's able to find evidence for it. So I mean, I think it indicates that it's a real concern. I mean, we don't have evidence of a methane bomb happening right now that we can see, but who knows? you know.
Well, it's certainly a very big problem. I was always angry that their work was being disregarded, and I thought it was because, I thought it was because, first of all, Chakova's a woman, and secondly, she's Russian, so there's two strikes against her, and which would tend to lead to her work being neglected, and so then, of course, there's the probability that, or the possibility of her work being very important, but deliberately neglected because for political reasons.
Or why would any politician care one way or another whether a particular level of methane in the air was coming from this part of the ocean or not? Who cares? I mean, politically, I can't see why they would disguise things. You're
Well,
Yeah.
Matt, I would say there are two politicians who I can think of who have a great interest in having the Arctic melt as fast as they can, so they can drill out the oil
Yeah.
and explode with the rare earth elements that they think are under there. And there are two politicians who want to see this happen as quickly as possible.
All right. Okay, and you think that they would actually not want it to be known that there are releases of gas because of the warming?
Well, that's not their concern. They're concerned about the money that can be made now, not what's going to happen to our grandchildren. That's not their concern. They want to make that, they want to drill that oil and mine those metals now and make money now. That's so.
I had an email saying we Canadians should be developing the sea lanes, in the Arctic. I'm really amazed that people talk about it as if there are no implications, and it had nothing to do with, how the rest of the global warming was proceeding.
Well, of course, there is no global warming, so therefore it doesn't affect anything. So therefore, this whole thing that is not a problem. the, the, but there is huge amounts of material, rare earths, which are sitting there, waiting for somebody to come and grab them.
Look, let's go back to these big craters in Siberia, because I've seen photos of those, and what I wonder is if, let's say, I don't know whether they're all, how much variability there is in the diameters of, the size of the explosions and so on. They all look to me to be about, like a 2 or 3 square blocks of, except they're not square, they're round. But if something like that blew up, and of course there's not a lot of folks around there, so it is quite possible that they blow up and nobody knows about it until years later they discover them. But would that be sufficient to account for increases in methane that would be detected by, I don't know, Tom, are you talking about satellites or planes or what, that detect these locations of methane concentration? Would a plane be able to pick up something like that if they did it within a day or two after the explosion?
Well, let me answer that. I mean, the thing is, methane is well mixed in the atmosphere because it lasts about 10 years or so. So it's very hard to see sources of methane against that well mixed background. So that's really one issue. Now, the thing is, there is a new satellite that was put up that basically focuses on small areas. It's trying to find small, intense sources, such as flares from gas, leaking gas pipes and people burning it and all that sort of thing. And that's just gone up. But in fact, that doesn't cover the whole world. That covers places that they choose to look at. So they say, well, let's look at this particular refinery or that particular, location. So anyway, but they are now able to track these sources to some degree. But they're not seeing much showing up in the general background. That's kind of surprising.
Well, it makes me think in terms of maybe, barrels of some kind of a thing that was deposited in the ocean just as a dump, that maybe something happened there. Is there anybody who would have any reason to deliberately puncture one of those things or deliberately set off any kind of explosion of these, what did you say, some kind of carbon monoxide, did you say?
Well, there's a lot of carbon monoxide. There's a lot of everything except methane that you'd expect with a huge explosion. That's what's so bizarre about it.
Yeah.
I don't know what it was, but I really don't. I mean, I don't think it was a methane bomb because there'd have to be a methane signal of some kind, but I don't see it.
But now, nothing like that would explain the heat, that the local heat in the fact that the North Pole was melting. Right?
Well, no, not really, because that was a local event. I mean, the thing is, the ocean was already 7 to 9 degrees C warmer than normal at that time of year. Whether that had a triggering role or not, I don't really know. It's no. But I mean, the thing is, I say there's lots of, unexploded ordnance and pollution in the ocean, in the United States, all across the Pacific, all around the Arctic, and Canada has piles of it too. Okay.
Oh yeah, I'm concerned about the forest fires and the amount of carbon that they'll be depositing on the Arctic. There might be things like that going on in the Antarctic too that I don't know about it, but I've only heard that I mean, in fact, Peter has shown photos of the Arctic that where the snow looks practically black. Now, would a thing like the LA fire, which is big enough, I guess it qualifies in size to one of the forest fires or something, but would that
No, that was a small forest fire on the scale that we're talking about. The forest fires this year in Siberia and in northern Canada were vastly greater. The LA thing was just like a campfire by comparison. And the Canadian and Siberian fires, a lot of those ashes and stuff blew right up onto the Arctic ice without any question. No one tracked that yet. I think Liana, when she gets back from her cruise, she's going to have something to say about that. But definitely, this last year, there were huge particulate sources on Arctic ice, and we're going to see that signal next year. The other thing is that also we're in an El Nino. I mean, basically, NOAA's so far out of phase, they're still saying we're in a La Nina, but we're actually already in an El Nino. And,
sorry,
the warmth of the
explain
boots
that.
on the last 2 years is not going to go away. It's going to accelerate, I'm afraid.
Okay, now hold on, because now you said something I don't understand. I thought we were coming out of an El Nino.
We did a year or so ago, and we're sliding into La Nina, and it never really fully developed. So right now, I track sea surface temperatures worldwide every morning off the coast of Peru. It's really hot going up to the Galapagos. So what was a La Nina that was supposed to be developed, I say these guys are out of phase. They're totally out of phase when they make their predictions with the reality of the situation.
But I thought El Nino
we're going to have an El Nino this year. I'm pretty certain.
I thought that El Nino was a regular, predictable thing that about how often it's going to happen.
It's totally unpredictable. That's the thing. No one can predict it at all. It's an irregular oscillation, and we just have to look at the data and have it tell us what's happening. But nobody can predict it accurately.
Can you guess why? What's the theory about what causes it?
Oh, well, it's a sort of a pressure oscillation between the west and the east Pacific. So that basically on one side, when there's high pressure on one side, there's low on the other, and vice versa. It kind of oscillates back and forth. And so that drives the temperature and the winds all across the Pacific, which is half of the planet. But no one can predict it. Absolutely no one can predict it.
Yes, I agree that you've got these things occurring in random intervals, then you've got to assemble enough evidence that man is doing this, and and the difficulty, as you say, is that the biggest candidate, the most obvious candidate for anything dramatic in the Arctic is methane. If it's not methane, what is it? If there's some spectrum of gases that are associated with some kind of explosion, are they a spectrum that is you would be able to say finger it as something evil now that the Russians would do, or is it something which is a natural phenomenon, and it just happens to be something that we don't see the methane component. So it's a very interesting problem. I mean, we really should, in which case we should be monitoring it like mad. We should be monitoring all the gases released.
We're sort of having a proxy war between, the U.S. and England, and NATO and so on, versus Russia in this Ukraine situation. And I used to go to Russia every year at least, and I had a lot of friends in Russia. But once that war started, I pretty much broke off contact because some of them don't want to have anything to do with me because they could get in trouble, if they say something that the government doesn't like. But that's a social relationship that it makes me sad because it means really kind of the end of friendships. But as far as research goes, I'm wondering how much, if any, impediment is there in the exchange of scientific information between people in, say, Europe and North America and so on, and people in Russia. Have you been in touch with Russian scientists? And have you found, in fact, parenthesis, I did at one time try to get a Russian scientist to be on my talk show since the war began. And he was almost rude to me. He was made it very clear that he didn't want to have anything to do with me, and it was, he agreed with his government. So, apart from whether or not he likes you, would you find that Russians would be intimidated or afraid to share information with you or to collaborate with you on some sort of research project? And I'm asking both of you because I don't know how many times you've actually tried to reach out to people in Russia and what kind of response you've found.
Certainly, there's barriers now to the exchange of information, and it's a pity because this is a critical time in the Arctic when we should be using all the sources of information, which include a lot of data from bases all over Russia, which were previously open to us and are now not.
Tom, have you had any contact with Russians, and have you noticed?
Well, yes, I did, and that's actually interesting because when I was trying to research this issue about methane measurements in the Arctic Ocean, I was looking, first of all, I used Shakova's papers, and then as Peter mentioned, it disappeared. So I started searching, and I tracked down a Russian researcher in eastern Siberia, in the Arctic Ocean, called Boris Bukhanov, and he sent me a bunch of reprints of his papers on in situ. I asked him for a paper on in situ bottom sediment temperatures in Siberian Arctic seas, current state of subsea permafrost in the Kara Sea versus Laptev and East Siberian seas. This is basically going all along half of the Arctic, and so he's one of the people actually measuring temperatures there in these waters. And so he sent me a bunch of papers, and then what he said is he had data of bottom sediment temperatures as well as water temperatures of the Laptev Sea, and he didn't see any difference, and therefore he didn't think that there was likely to be a big change. But anyway, he sent me about half a dozen papers, but the thing is that he's been basically frozen out. I sent him at that point an article that appeared in the New York Times, and that was on Russia's warming Arctic as a climate threat. War has shut scientists out of it. And that appeared in the New York Times, which is the date on that? October 22nd, 2024. And, I sent that to him because I thought he would be interested. And his response, and I don't know if I could have been getting him into trouble. He says, I am a scientist, not public. I have no information about any collaborations between Russian scientists and foreign specialists in permafrost and Arctic research now. He understands that Professor Romanovsky, who is a Russian researcher in exile, who is complaining about the Russians being frozen out of it. And he says, I and my colleagues often encounter this when we try to publish our scientific results. And I've just found a bunch of cruise reports, and he sent me a whole bunch of papers. I'll forward this stuff to Peter because I think these papers will be, are more use to him than me. But basically, the thing is that he might be even getting into trouble for having email with me. But the point is, science is a global language. And all of humanity suffers when knowledge is held back by politics and religion. And that's what we see happening now. And, the Russian Arctic scientists have been frozen out of the international arena. They're obviously still working away. They're doing their thing because that's what they know how to do, And you got to admire them. You got to admire these people for just continuing on despite the situation, just like people in the United States are, I live in the U.S. We're trying to do what we can despite the situation, and so are the Russian scientists,
Yes, and the U.S., by the way, has this new challenge that I read that I don't know how true, it's everything's happening very quickly. We're only 2 weeks into the Trump regime, but he's cut off the place that's keeping records of world temperatures, global temperature
Yes, we
monitoring.
don't yet know. That's right. Well, they go after NOAA every time because they don't want climate change data, but then they realize that climate change data is weather data, and if they don't have weather data, they're not going to know when the next hurricane is going to hit them or the next winter storm. So that's a big issue. Republicans want their forecasts; they just want them to be really short term, you know. But at any rate, so that's what happened there. I mean, they had to save it because all the farmers would be complaining if they couldn't get their weather forecasts. All the people sailing their yachts couldn't find out whether they're going to go into a storm, you know. So I think that it was threatened. I mean, I use the satellite sea surface temperature data every morning. That's what I work on. That's my bread and butter. You know, it could disappear tomorrow, but I hope not.
That
Yeah,
you can
I
still
hope not to.
you can still get everything at the moment. You can still get everything at the moment. I mean, I've had ghastly stories from contacts, like in Noah, that there won't be a Noah, in a
Yes.
while, stuff like that.
NOAA could disappear any time. The guy who was just appointed chief scientist at NOAA is a guy who was involved in that fraud where Trump tried to redirect a hurricane to Alabama. Remember that? The Sharpie Gate thing where he simply drew a black Sharpie pen and redirected the hurricane at 90 degrees from the direction it was going. And I mean, and the guy who backed him on that is now the chief scientist of NOAA or
Oh
the
my God.
director or whatever, you know. You couldn't make this stuff up.
No.
Well, Orwell saw it perfectly.
But the appalling thing that awaits when the world becomes sane again, things like the amounts of data lost, the amounts of insights that are completely lost, and crazy conclusions reached.
But
Gosh,
how much is it going to impede international research? I mean, climate change already has not been very satisfactory. If you look at, what goes on in the COP meetings and so on, it's just not, because it's so controlled by nations, and what gets published is vetted by representative nations who have their own agenda, and they water down conclusions and even remove language that they don't like or terminology they don't like and so on. So it's clearly been already handicapped. Research is not everything it should be, but how much is it going to be impeded by these new? I mean, if the U.S. continues on the path that it's doing, which is just cutting off all kinds of scientific research and institutions that are supposed to be handling research, and there's no funding and maybe even nobody is allowed to do things. How much is that going to handicap your work, both of you?
well, I think pretty enormously, but you're in a way, scientists are kind of used to having to work to create bricks without straw. They can switch themselves into modelling mode and produce lots of, which of course is being done at the moment. You see lots more modelling papers than there used to be, and fewer data papers. So a scientist who is not allowed to do observations anymore is going to do modelling instead. She can't do it with going out and measuring things in the field because it's the wrong field and the wrong country. Then you can do observations from models and work away that way. It's not a great way to operate.
Tom, how much do you find you have to watch out for your own research?
Well, let me say this. I mean, the thing is that the U.S. has dropped the ball on satellites several times before. They did on the satellites that monitor Earth radiation balance in both the Bush administrations. That's why we don't have adequate data. Both of them sacrificed essential satellites that were really needed to know how much heat was going in and out. But at any rate, I mean, the European Space Agency and the Japanese and other places have sort of taken up much of the slack, and hopefully China and India will soon too. So there's going to be definitely a gap. Now, the thing is, since there are other satellites out there, there are others that are able to monitor, say, the stuff Peter does. Now, in terms of my own work, I invented the satellite, the coral bleaching hotspot method for predicting coral bleaching and these extreme events. And so NOAA has a satellite, a whole site that's dedicated to that work. If that goes down, my work is at an end. There's no way that I can see which reefs are hot, when, and where. I mean, and let's talk about that another time, because we have a paper out looking at the global changes in ocean circulation and bleaching last year that really tells a huge story about why it's gotten warmer in the last year or so, because it's related to ocean circulation changes that aren't in the IPCC models, as you'd expect. But anyway, that's a discussion for another time. But I mean, if NOAA shuts that site down, my work is finished. There's no question about that,
Now, there's no
there is another
question.
site that does that.
Obviously, we need to come back and revisit all of these topics. I think we're not through. We're only able to kind of speculate. Maybe there's more evidence that'll come to light, and that we can pick this up and talk about it some more another time.
This is for another time. But I mean, the thing is, as you know, I'm an equatorial guy. I don't like to be cold, but the thing is, my family has long ties to the inland Eskimo of the barren lands of the Ahiarmiut people, who were the so-called people of the deer. And my grandfather lived with them when they were starving to death on the tundra, and when the Canadian government forcibly evacuated them. And so I have the photographs of them, and I'm in touch with them. I've given them all the old photographs of their life in the tundra. They've never been back. The whole tundra has changed. And what's interesting is they were forced into exile in Arviat on the Hudson Bay. And that area was under 3 kilometers of ice in the last ice age. And it's the area where the crust is bouncing up the fastest in the world. They don't have a sea level rise problem. They've got the worst sea level fall problem in the world. Every year when you go along the beaches, there's a new beach ridge, a couple feet high, that formed that year. The land is rising out of the sea. Islands appear out of the Hudson Bay. When they go hunting in Hudson Bay, their propellers break on rocks that weren't there
Why?
the year
What's
before.
causing that?
Because after the ice melted, the whole land is lifting back up. Okay, that takes thousands of years. When they go in their kayaks to go up the rivers to hunt for the caribou, and that's what they live off, is the caribou. The rivers are all drying up. The land is being lifted up, so the rivers are drying up. The tundra is just full of all these lakes that are all dried up. Instead of being full of water, they're full of dry, what was mud, and that's degassing huge amounts of methane and CO2 into the atmosphere for sure. And no one's measuring that, because the Arctic Atmosphere Monitoring Program is flying U-2 planes at 30,000 feet up in the air, or more. So no one's measuring the sources on the ground, but their whole land is bleeding some of the highest levels of CO2 and methane anywhere in the world into the atmosphere because of that phenomenon of uplift. So their whole life is changing there, and very dramatic. And that's something that's going to affect, say, the Greenland people. I mean, no one's asking them what they want. Okay? And the same thing is true of the Inuit and the other people in the Arctic. No one's asking them what they want to do.
Okay.
Yeah.
Have a good day.
Let's see if you can get hold of Ileana when she comes back from the Arctic. I'm sure she'll have a story. If we can get hold of Weldiab too, that'll be some interesting geological stories there as well.
All right.
It's
Take care.
fascinating that you know the people of the deer. That was my first introduction to the Arctic.
Yes.
Was Farley Myatt's book, and then the follow-ons when they were looking at what happened to the
Yeah.
people, individuals who were being who were had such difficulty in surviving. That was really quite.
Okay, so small world. All right. Thank you, friends. Take care. See you again soon. Bye bye.